Hi, welcome back. I'm Terry Burns, and this is a continuation of my course in the Monas Hieroglyphica or Hieroglyphic Monad of John Dee, using the translation as usual that I did with Nancy Turner that came out a couple years ago from Ouroboros Press. Those of you who have been following along with me all this time know that we are up to Theorem 23. We're past the most difficult part of the monad, and we're on the sort of downhill slope to the end of this great work. So let me share my screen here as I usually do. As I have mentioned before, this 23rd theorem is long, but it's pretty easy. It's especially easy compared to the couple of theorems that have come before. The first half is drafting instruction. The second part is columns of numbers. We're going to do the drafting instructions here today. I usually give a kind of spiel here now saying that I assume you know who John Dee is, you know what the hieroglyphic monad is, da-da-da-da-da. Actually, you don't have to have read or understood any of it to understand what I'm going to talk about here, though if you don't know who Dee is or what the Monas Hieroglyphica is, I'm not sure why you're watching, but welcome. Anyway, if you're just joining in now, I'd love to have you in this course, and I have 4 different playlists below. But you do not need to know everything that came before to make sense of the drafting instructions in this theorem. The more you do understand, the more that you will catch his in-jokes, and Dee loves to make in-jokes, but it's not in any way necessary. So let's go ahead and get started here. It starts on page 94 in our translation. And by the way, some of you have asked about physical copies. I'll drop a link below for those of you that are interested in that. So Dee starts this theorem by saying we've already held forth on the symmetries present in the hieroglyphic construction of our monad, as we have observed, and which we would like to be observed by those wishing to place it on signets or seals, or to use in other ways. Now, you probably know, if you're interested in this, what a signet or seal is. You may even remember back in the letter to Maximilian, him talking about this Gamea of earth of marriage. His Gamea is a kind of seal that's earth of marriage. Some of you know his later Enochian work. You know of his Sigillum di Ameth, seal of truth or God. Some of you even used magical seals. But if you don't know or you don't want to, don't worry about it. We'll just keep going. Okay, now, what I just said may have sounded kind of snarky. In fact, it was. The tone that you get from Dee, if you're reading this in Latin, underneath the seriousness, because this next sentence on one hand could sound in Latin like it were part of a Latin mass, even though it's a Protestant Reformation. Dee is now Protestant by this time. He started out Catholic, but it has that cadence of a Catholic mass with snark underneath. It's fascinating. Anyway, so that is Dee kind of, I would say, winking at the initiate who understood theorems 21 and 22. So he continues, he says, in the name of Jesus Christ, who for us was affixed to the cross, and whose spirit I wish and hope to be writing through my pen, we now seek to measure our cross of the elements. Notice that his saying Jesus Christ, who was affixed to the cross, the crucifixion is here presented in a way that you can take as totally doctrinal, and you can't in 21 and 22. I mean, they would be heretical. They're laying out a path of the initiate, which is basically for you to have the same revelation of the afterlife that Dee had in 20, for you to become an anointed one like the Christos, and all kinds of things that he really can't say. But this sentence can mean the doctrinal understanding of the crucifixion. Now, it wasn't our mystical or anagogical reading, which I just told you, and I'm going to just toss that line in again. But if you don't know what I'm talking about here, don't worry about it. It's not going to affect your ability to follow his instructions. Okay, so he says, indeed, we do this according to the proposed material argument, because everything begotten under the lunar heaven has its beginnings either joined out of the 4 elements or is itself a pure essence. And this occurs in various ways not commonly known. What are those various ways? Well, the ways he's discussed all the way through the monad, right? But also, there are some other things here. if you have been following along, first of all, thank you. It has been so wonderful to have someone to talk about this stuff to. And second of all, think about the thing I said last class about measurements and why I gave you that last homework assignment anyway. So what cross of the elements is he measuring? Because he says this is a proposed material argument for everything under the lunar heaven. That's the so-called sphere of the moon. You may know where the sphere of the moon is, say on his seal of Amet. Many people in medieval magic and long before that use spheres of the moon, continues all the way up to the time of Kepler. You can also equate it Kabbalistically with Yesod, but as you know from theorems 21 and 22, that's Yesod in the world of Asaya, Yesod of Malkuth. It's only from there down that measurements make sense anyway. That's where you can measure things the way he's doing it here. And one more time with the snarky line, but if you don't know what that means, don't worry about it. You can still draw the picture here that he's wanting you to draw. Okay, we'll continue on. He says, this occurs in ways not commonly known, right? Because that's what he's been doing all through the monad. He says, although those elements are not created in equality, something or some circumstances, as the wise will know, can lead them back to this. That's the whole motion of his hieroglyphic monad and the initiatory path in theorems 21 and 22. We constitute in our cross equal and non-equal parts secret. Oh, so the measurements aren't perfect after all. What else is secret? Hold that thought. Which from a different calculation, we can call the same and different, or the one and the many, while in admitting, as we taught above in the earlier theorems, this as a property of the equilateral cross. And that's exactly what he's done. He's taught about the property of the equilateral cross, but he's going to give you a cross that is not equilateral in his drafting instructions. But if we placed here before you, one after the other, the calculations, which we have, for the symmetries we have hoped to bring forward in a manner abundantly adequate for the wise, or demonstrated the causes for the design of this entire small work, we would have leapt across the limits that were judiciously prescribed for us. So, his property of the equilateral cross. What are some of the properties of the equilateral cross that we've talked about? It's a property of the equilateral cross that allows it to be flipped into so many perfect forms like he did, particularly because now we're shifting sort of from Kabbalistic thought to sacred geometry, and the final fusion in his course of study would probably is bringing those together. But remember, you had the rectilinear cross, right? 4 right angles, recta in Latin, which means recta can mean line, it can mean a right angle, it can mean rectitudinous, it can mean the ascent towards the good. It's like the Gnostic ascent to the one, all those things that we talked about, but particularly talked about in the first really 5 theorems, maybe the 10 theorems. So then if you flip that cross, the center out, you get a square, you flip it again and you get a cube. In Platonic thought, that Platonic solid is related to Earth. So what is the secret, the something or circumstances? Many things, but there's one in particular I want to talk about here. You remember at the end of the last theorem, we had talked for quite a few videos about how he's setting up the path of the initiate and you being the vessel in theorems 21 and 22. So if you get an outline of that thought and need a kind of teacher, what is the course of study that you're going to get from that teacher in terms of Kabbalah? And I said I'd continue here talking about that in terms of sacred geometry. Well, that's what I want to do here just briefly, and then we'll jump into the drafting instructions. If you're not interested, just, move the YouTube video ahead to the drafting instructions. So think about the energetic properties of cubes, because D's temple space would definitely have been a cube. I know there are some students here of Dan Winter who often has talked about the energetic difference between something made out of cubes, or in effect squares, and something made out of a golden rectangle, or a golden rectangle flipped into 3D. And it's really a profound thing. One allows a kind of privacy, a cube, for energetic reasons that have to do with embedding wave shareability and all kinds of things like that, that D would not express in that way, but which map back here perfectly. But the golden rectangle, on the other hand, is something you see a lot in the all kinds of beautiful architecture. Now, I'm going to drop a link from the FractalU that Dan runs, a presentation that my friend Tufan Guven gave on fractality in nature, in architecture, and so on. But it's that kind of course content. So even things like how you get a golden rectangle, yes, in architecture, yes, in Vitruvius, the great classical expert of beauty and architecture, but then Da Vinci takes those proportions and puts them on Vitruvian Man. You get the kind of thing that is now called a fractal, a word that would not have existed in Dee's time, but the concept certainly did. You get it in things like pentagrams. If you are continuing with Alan Moore and I in a couple months in our class on Dee and Kelly's Enochian work, we'll talk a lot about pentagrams. Well, a lot of that will, as we'll show you then, comes right out of the hieroglyphic monad. Anyway, you get, if you use the square, you have to have a square to make a golden rectangle. And what can you do with a golden rectangle? And as you make fractal other golden rectangles, well, you get a phi spiral. You get that numerically expressed in the Fibonacci sequence. It is true that that's not mathematically called the Fibonacci sequence until, the 19th century. But the Fibonacci guy is from 1202. I mean, the idea was known. It just wasn't expressed the way we express it mathematically today. This also becomes very much imported into later Rosicrucian works, measurements of the temple and that kind of thing. So his initiative course of study having to do with sacred geometry would be that sort of thing. And again, let me direct you to Tufan Guven's excellent introduction to fractals and fractal geometry, which I'm going to drop in below. All right. Now, he talks here also about symmetries. He's talked about that before. In geometry, an object has symmetry if you can perform a transformation on it. Remember back to that LVX theorem, Theorem 16, where he's taking L's, V, X's and rotating them around. You have symmetry in a geometric sense if you can translate an object, like take the L and move it up or move it down, move it around. Well, if you move it this way, that's rotating it, another kind of symmetry. You can make it bigger or smaller as long as it keeps the same proportion. You can mirror it, and he's done mirroring many times through here, in such a way that the figure can map back upon itself. Then it has total symmetry if you do that. Now, in Euclidean two-dimensional geometry, which is the geometry of the so-called Euclidean plane, which we talked about in many different ways with conic sections, with that parabola and so on, and the parabola and the solution to the Delian problem in Theorem 20. Symmetry is a very important concept. You have the same thing in three-dimensional Euclidean geometry, which would in effect be both of those would be modern Cartesian geometry. It's not the kind of geometry where between, think of three-dimensional Cartesian geometry, which is in effect a bunch of stacked cubes, right, going out in 3D. Compare that to the geometry of someone like Buckminster Fuller, who is having kind of interdimensions within that cube. So when Fuller talks about fifth and sixth dimensions, it is in Cartesian geometry basically three-dimensional geometry that is kind of on its way to fourth dimensional geometry or interdimensional. All right, so But if you're sticking with, and by the way, James Egan, who has 2 books with his exploration of sacred geometry and number in the hieroglyphic monad, and I will drop those in below. He argues persuasively that the geometry of Buckminster Fuller is that which most applies to the hieroglyphic monad, and I would totally agree with that. I haven't mentioned Egan's work a lot through this course because Egan is not at all concerned about whether the things he's talking about with vector flexors and things like that are things John Dee could have known. Same thing with Dan Winter and his wonderful FractalU presentations. So I've tried to keep 2 things either that Dee could have known or that could have been reverse engineered from the Rosicrucian works that he influenced. But at this point, let me just give you that later course of study in the as links below. Okay, so Dee has been setting things up so you can manipulate them this way all along, and you have seen him do it. So take his Tau cross, for example. In Christianity, there is a symbol that is a Tau cross. It's the Greek capital Tau, which looks like RT. The small one, now that isn't symmetrical in all directions. It's vertically symmetrical, but not horizontally symmetrical. But if you manipulate the bottom part so that it's an equal length as the top 2, and you flip it over, you're going to get an equal armed or equilateral cross. Remember what Dee did in the last theorem with his alpha, tau, omega, beginning, middle, and end, and they're joined, alpha and omega joined at the cross of the elements. He was drawing a lowercase tau, not the capital one. So the lowercase one he manipulated so it looked like his cross of the elements. Maybe not exactly, but enough that you had that idea. And he has done little sort of distortions like that with his figures all the way through. Think of what he did with the planetary glyphs to make them symmetrical, at least on one axis. Okay, so let's go to the end here when he says we would have leapt across the limits that were judiciously prescribed for us. What are those limits? Well, in one sense, those are just the limits imposed by straight edge and compass construction. And I talked about that back in the very beginning of the theorems, the first 3. Straight edge and compass constructions are the way that you are supposed to solve problems in traditional Euclidean geometry, doing ancient Greek geometry the ancient Greek way. So you are contemplating on perfect forms and then demonstrating the fruit of your contemplation by the proofs you're doing with compass and straight edge, which you can also then sometimes in some situations mentally flip into 3D. So there are 5 basic principles here. The first is you create a line through 2 existing points. The second, you create a circle through 1 point and use the center as another point, that line segment marking the circle's radius. The third is to create a point which is the intersection of 2 non-parallel lines. Fourth is creating 1 or 2 points where a line and circle intersect. The fifth is creating 1 or 2 points where 2 circles intersect. And these applications are going to govern everything Dee does in discussing how to draft his monad glyph here. But it also corresponds directly, say, he begins by drawing a line that corresponds to the first postulate in Euclid's Elements, which, remember, he wrote the introduction to the first English translation of that, which was by Billingsley, and that came out just a few years after the Monas Hieroglyphica. But these limits have another sense. In another sense, they're cognitive and/or educational limits. You have to have understood what came before. And what you understand will depend on how much of that you grokked, so to speak. That is, there have been many, many people in my lifetime, in a century before me, probably since Dee's time, that understood the opening theorems, or thought they did. I mean, maybe they didn't get the allusion to Genesis, or maybe they did. Maybe they got allusions later to Timaeus, or maybe they didn't. But then, though that person might have been totally mystified by what comes along later, but then they get to Theorem 23 and it's like, oh, I get it. no problem. It's just that the most important things in there that person might have missed, but they can kind of tune back in, so to speak, in 23, which might mean that they ignored the place in 21 where he told that person to go back all the way through. But anyway, that many readers have done this. And in fact, someone who has never read this work, but who knows Euclidean geometry, can easily follow the drafting instructions he gives you here. And just the opposite of that is true also. If you conceptually understood what he's talked about, but you're really bad at compass and straight edge constructions, it might be hard to follow what comes along here. All right, so let's go along and see what he says after he says we would have left across the limits that were judiciously prescribed for us. He says, having chosen any point on a plane, for example, A, let a straight line of sufficient length be drawn through it from either side, and let this be CAK. And on line KC at point A, let a perpendicular be erected on either side, led outwards towards a sufficient longitude, to infinity, as the geometers are wont to say, correctly so, for it prevents inconvenience, and let this line be admitted as DAE. Next, let a point be chosen on AK, wherever it is pleasing, and let it be B. So what he's doing is telling you how to measure or draft his symbol using straight edge and compass construction, as I've said. And remember, recta is translated as straight line, less often as right angle, but it can also mean, along with rectitude and all, it can mean a straight edge. And the idealized Greek straight edge was assumed to be infinite in length, like a line, which is what he said to infinity, as the geometers are wont to say, for it prevents inconveniences. But if you try to do this, you will find that the real inconvenience he's talking about is totally mundane. It's that if the line goes to infinity and another line goes to infinity, you have plenty of space, right? So it doesn't matter where you put the point on that line. But if they're line segments and you put the point in the wrong space, you may run out of paper, as we will see very shortly here. Anyway, another really important thing here that I talked about, again, way back in the opening theorems, is the kind of grammatical structure used in ancient Greek mathematics. And here he's actually emulating that style in Latin, including Euclid's Elements, but not only limited to that. Now, my two favorite writers on this topic are Fowler and Tasbeck, and they coined a term that many other people who write on ancient Greek geometry have used. It's called the helping hand. So it's this construction you get that it's like this, there's this helping hand around because the writing is in passive voice. It's actually in this very complicated grammatical case, which is the passive voice. It's passive voice imperative, which is hard to do. It's like let it have been dropped, and then have makes it perfect. So you get the future passive imperative perfect. That's a really complicated verb tense, if you're into verb tenses, which I guess I kind of am. But as Fowler and Tasbeck says, this helping hand is always there to make sure perpendiculars have been dropped, or lines have been drawn. And the implicit effect of it is like there's this hand watching over, helping you. Why would that be? Well, because in Pythagorean thought, these are the revelation is, in this case, not angelic revelation, it's the revelation of perfect forms. That's what you have been contemplating. And so that is why that verb tense is there. It's really a beautiful kind of thing for the rarefied few people who read ancient Greek mathematical text in ancient Greek. All right. Now, I'll show you what I mean by running out of paper, though. All he's saying here is, here's a straight line. This line is supposed to be infinite, right? But I cheated and made a line segment, and pretty quick I'm going to run out of paper. But okay, so I pick point A, and I have this line, CAK, then I have the next one, DAE, and so on. And that's great. That's working just fine. But you can maybe already eyeball that and see that the monad isn't going to fit there. If you're not good at drafting or you make your lines too short, you might have to start over. Also, these lines have to be perpendicular. That's really easy with a computer program. It is not easy if you're just freehanding it. It's almost impossible. The same thing with drawing a perfect circle. That's why the compass and straight edge are sacred instruments, why you see them. Now, sometimes the straight edge turns into a drafting square. That's because if you use compass and straight edge to even draw a perpendicular, you've got to draw a circle, and then you've got to draw another circle, which means you're going to have a vesica piscis. Remember us talking about that again in the first few theorems? And it's really complicated just to draw two perpendicular lines. You might or might not have studied that back in high school. I'll drop this link in below that will just give you a visual of what you'd have to do to get perpendicular lines with compass and straight edge rather than a drafting square and straight edge. All right, moving on. You also, if you're actually going to want to do this, you might want to get some graph paper. You might want to know that this is going to exist within a 4x9 grid. So even though I've got drafting paper over here, I have 7 squares stacked up on top of each other, not 9. So this is going to get really squished up unless I start using these little squares, and then it won't be big enough. So even if you understand the monad well, my point is, doing this takes some skill in drafting. But D, as we're going to see, well, we kind of know D is a bit of an intellectual snob from his comments about rustics or his letter to the printer where he said, this may just drive some people crazy, don't let them read it. But he's also here, if you want to not do it the ancient Greek way, you get the sense that he doesn't really care because he gives you the exact dimensions on the same page. And by the way, this is the thing that showed up in Athanasius Kircher's later Oedipus Egyptus that was like absolutely, he is talking about the Monas Hieroglyphica because it's this exact drawing, and he's talking about drafting it almost the exact way D is here. Okay. What I have here is from the 1564 one. Next to it is the one from the 1591 Frankfurt edition. Now you may wonder why there are straight lines across the top there. That is one of a handful of differences that I found between the two editions. And where I found differences, it seemed to me that the differences in the Frankfurt edition were places that were kind of a nudge to the reader. Remember, if you were following along with the flip monad, how they have a flip monad on the back cover in effect, long before it shows up in D's text, so it's always kind of in your mind. So why would they leave this here? Because you're going to have to erase lines, and some lines have been erased, right? Look over here. This line that went through was erased. And there are actually some other things, if you did it in pure compass and straight edge, where you have all these circles to make the perpendiculars that have been erased. So why are they leaving it this way? Well, I would submit it's because of the things that a later teacher might tell a student about sacred geometry. I can't prove that, but for example, there's absolutely no reason to not erase these lines in the circle here. They don't need to be there. But that makes it look like, oh, these are drafting instructions. And unless I know how to draft this, I'll just think, oh, okay, this is what you get if you're trying compass and straight edge instructions. It's not. You'd have a lot more of a mess of lines there and have to erase a bunch of them. How about these lines at the top and bottom? I mean, these are all things that you have to draw. It's just they should be erased. Well, what does that remind you of? Put another line in here which isn't drawn, because that's not something you need to do in your drafting instructions, right? But if you did, it would imply a golden rectangle. And I think that's the nudge you're getting in the 1591 Frankfurt edition. Now, since this is a 4x9 grid, is it exactly, I mean, did I say triangle? I meant to say golden rectangle if I just said triangle. Anyway, it's not going to be exactly a golden rectangle, but it'll be close. It will remind you of the idea. I would suspect there are people here watching who have participated in ceremonies, in chambers that are supposed to be golden rectangles, but are maybe off by a few inches. Anyway, there are some other things that you can come up with if you actually draft this. I am fascinated by this concept that Clay Holden had from his study of the Monas Hieroglyphica, and this is how that concept is reproduced in Duquette's Enochian Vision Magic, and I'll drop this link below. What he does after he's finished, then he puts another circle around and so on. And I'll tell you the significance of what he finds here after we're done drafting things. But I also was cheered to see that Holden was also, like myself and Alan Moore have done, looking for parallels between the Monas Hieroglyphica and the later Enochian work. And then he stumbled upon some really cool things that only peripherally have to do with Enochian. Back to that at the end. Okay, we are going to go on here and continue with his drafting instructions. All right, so then he says, having chosen any point on a plane, for example, A, let a straight line of sufficient length be drawn through it. We read through all this already. At point A, let a perpendicular be erected on either side, led outwards towards a sufficient longitude. To infinity, the geometers are wont to say, correctly so, for it prevents inconveniences. And you have seen how the inconveniences is, you know, if it's you don't run out of paper if it's infinite. And let this line be admitted as DAE. Next, let a point be chosen on AK, wherever is pleasing, and let it be B. Having now first established AB, clearly the common measure of our work. That is important because, as I told you last class, this measure, AB, is 1. That, in terms of the overall understanding of the whole Monas Hieroglyphica, is the most important thing, because what does monas mean in Greek? Unit, often translated as what you're setting as, well, unit is often just becomes 1. It's whatever you are setting as 1. So that's the basic unit of magnitude. Okay, in this place, thrice can change from A to C, so this is 3 units. Now, is that important? Well, think of all the times he's talked about a ternary. So 3 is very important to D, but whatever the esoteric illusions or allusions to things that he's talked about before, this first means that line segment AC is 3 times as long as line segment AB. AE is twice as long as AB. DE is going to be 4 times as long, and so on. If you read to the end of this, you get let AB double and be AE, and the double of AB would be AD. Accordingly, the entire line DE is quadruple that of AB. If you've never read the Hieroglyphic Monad and saw this, but you knew how to draft things, you might think, well, in fact, why is he being so verbose about it? Well, because that way he can wink and suggest other things. Let's see where he is suggesting other things. Well, he talked about that he hoped before that Jesus was writing through his pen. And down here he says, accordingly, the entire line DE is quadruple of AB. In this way, therefore, we have co-created our cross of the elements out of lines AB, AC, AD, and AE. And then he has a quaternary that can refer back to all his quaternaries. But I do want to point out that co-created is not a usual Latin word. So he's clearly implying here how he views his adaptation of Hermetic and Neoplatonic ideas, as above, so below, that he's co-creating an ideal Platonic form from below with the inspiration of Jesus from above running through his pen. And we will move on. After this, you have more drafting instructions. I think you can probably read those on your own without me going through, and you'll find that they exactly correspond to what you see over here. He does a couple things I want to point out that are interesting, though. He doesn't use the word radius. He talks about, when he's talking about his circle, that it has a center I and interval IB. He's used the word radius multiple times in the monad. And down here, when he's talking about the radius there, he uses interstitial instead of radius. So, except for those things, he's using the language of Euclid. And Euclid's third postulate is, let it be postulated that a circle can be described with any center and radius. So his readers have understood this as whenever there are a point and an interval between two given points, an opening, there is also a circle having the point for a center and the interval of the radius. So this has to be a nod to Euclid. And that's probably why he's not using the word radius. Or if you know Euclidean geometry, it certainly would seem that way. Now, you are invited to come up with other significant reasons why he has an II here, like we talked before about an MM. And if you look, you can find them. Will it change the basic meaning of anything? No, but jump into that if you like puzzles. Oh, and this is where I guess I was going to talk about a golden rectangle, not before, and why the Frankfurt edition leaves these lines there. So it's a nudge towards a golden rectangle, in my humble opinion. Okay, so having gone through that, he will again affirm that these are all requisite symmetries, explications, and descriptions of our monad. And then he says, nevertheless, it would please me to point out to the mechanic that the whole line CK consists of 9 equal parts of our one fundamental constituent AB. Mechanic, Latin mechanicum, in that preface to the introduction to Billingsley's first English translation of Euclid's Elements, Dee writes in English about a mechanic or a mechanical workman whose skill is without knowledge of mathematical demonstration, but is someone who can perfectly work and finish any sensible work by the mathematician, principle, or derivative, demonstrated or desirable. Well, in effect, what he's doing here is a kind of, well, first of all, drafting is very difficult. So it's kind of insulting to draftsmen, in my humble opinion, but maybe I'm getting too easily offended on their behalf. Nonetheless, what he is saying here is another kind of snark, like, get a good mechanic to draft this stuff. Sort of, it's your job to understand it, get a mechanic to draft it. Or that is how I would interpret it, and not only me. Why is he interested, though, that it consists of 9 equal parts? Why does he want to point that out to the mechanic? Well, actually, his mechanic, as it turns out, is a little interested in esoterica, because the one obvious thing that pops out here about 9 is 9 is associated with Yesod, the treasure house of images. And what is this? It's an image. What has transformed you if you follow the path of initiate set out the way he has in Theorems 21 and 22? The signs and symbols you contemplate upon are surely one of those things. When we get to the end of this, we're going to get fully horned, but let me just read what is between the two, because there are a couple other things that may be worth commenting on briefly. He says, from this one can enter into another way of doing the same work. Thereafter, the diameters and half diameters must here be traced, so say the mechanics, as invisible lines. No visible center should remain, except for the excuse me, except for the solar center, one seems marked by the letter I. No letters are to be attached. Then for ornament, not for any mystical necessity, which we would have considered already. In other words, if you see that pretty picture on your screen that's a lot prettier than the other depictions of the monad we've gotten, he's telling you to do this to make this seal prettier. for ornament. So then for ornament, not for any mystical necessity, which we would have considered already, the mechanic may place near the solar periphery a surface breadth, described as one concentric circle. The breadth of the concentrics actually can be made a fourth or a fifth of AB or nearer. Well, wow. For somebody who has been so exact, now it's like, oh, make it a fourth or a fifth, whatever looks prettier to you, that's fine. However, the line of the moon can be allowably curved, bestowing the accustomed sight as she appears in the sky after her conjunction with the sun, that is, fully horned. Well, there's all kinds of Renaissance puns with this about what fully horned means. After all, nature rejoices in nature, so you get the joke about being horned. But the mechanic can make the moon also look as it appears in the sky when it reappears as after the new moon, as Diana's bow, in effect. So, as he continues there, he's going to be similarly imprecise in his preciseness when he says, and by the way, then he'll use the word radius again after this. Parallels may be drawn forth on either side of the straight lines of our cross at about 1/8 or 1/10 the distance of AB. So his at maybe 1/4, maybe 1/5. Now, if I won't go into all the things you can do here, but if you wanted to study this in terms of sacred geometry, right now it is valuable to look at why a fourth or a fifth or an eighth or a tenth. I mean, there actually are some significant reasons for that, but I'll leave you that for you to explore on your own. So that our cross is, in fact, made out of four substances, four surfaces, pardon me. Although it's also, the cross has been made out of four substances. We know it's a cross of the elements. Anyway, quasi-lines whose breadth is a fourth or a fifth part of AB. I wish to outline these ornaments here in some way by the adjoining figure. All of these things each person may create to their liking, so long as the manner does not introduce injury or even the slightest to our mystical symmetries. They must not, out of laziness, throw into disorder this new discipline of hieroglyphic commensuration, which is far greater and more ample than we have been able or even wanted to explain in this little book, as truth, the daughter of time, God willing, will teach. When he says parallel there, by the way, parallel can mean either a parallel line or a concentric circle, which is what you're seeing in the drawing there. So he's basically saying that each part of the monad except the moon can be made wider so it looks prettier. And oh, and by the way, tapering things off like this using compass and straight edge constructions is a little bit difficult, actually. That's not usually how you do them. Let's see. That should say rectangle, but let's go to the four surfaces here. What would the four surfaces be? Well, he has implied when he uses four in terms of sacred geometry, several things, and he has implied similar four things about, well, we had the four worlds, we had the four stages when we were looking at the vision of Zosimus, but if we're keeping this at the material world, when he has four, anytime he does that, as we've seen with his rectilinear cross, you can flip it and you have a square, which is four sides. Flip it again and you have a cube. So four surfaces, the four directions of the different sides of a cube, and this is one of several places that he is implying a cubic space has his kind of chamber of reflection, if you will, temple space. Now, I did say I was going to come back and talk a little bit about Clay Holden's discovery with the monad when he drafted it. So I'll just tell you what Holden says about it in his introduction to Enochian vision magic. He said, in attempting to find a simple way to generate a regular heptagram in a circle for the purposes of reproducing the seal or the sigillum, and what's he talking about? The seal of truth of God, the sigillum de Emeth, which is the first part of the Enochian system that Dee and Kelly received a couple decades later, and which is in which the number 7 plays a significant role. So he says, I further discovered an interesting connection between the spirit diaries and Dee's earlier Monas Hieroglyphica. While one cannot in fact produce a regular heptagon in a circle using only compass and ruler, it's a geometric puzzle that goes back to the ancient Greek mathematical texts. Albrecht Dürer, by the way, the great artist of the Renaissance, as one of the many people who puzzled over this and one of the few who found a kind of rudimentary solution. He says, one can approximate it. And that's what I mean by a rudimentary solution. There are ways that you can solve the unsolvable problems of ancient Greek mathematics, like the doubling of the cube, the squaring of the circle. But in modern math, they're thought to be unsolvable simply because they involve approximations. Like anything involving a circle is going to have pi, so you got to find a fractional equivalent. So these are geometric puzzles. As Holden says, a geometric puzzle going back to the ancient Greek mathematical texts. But you can approximate it. There are several classical solutions, each of them rather close, but also involving complex methodology. Laying out the Monas Hieroglyphica in its 4x9 grid is given in Dee's book, using a compass from the midpoint to trace a circle and rotating the Monas so its horns touch on the circle. From the top of the grid, one finishes with a very close approximation of a heptagon. In fact, as close or closer than any known classical solution. I mean, that is awesome. Now, can you prove that that's something that would have occurred to Dee, or that? No, of course you can't. But would he have? Of course. I mean, this guy is living in a geometric and numerical echo chamber, as I've mentioned many times before. Anyway, that is perhaps some of the initiatory content that you might get with this theorem. So you can also explore more about that if you want. Dee has also clearly implied that the student needs to learn things about sacred geometry, particularly the relationship of perfect forms in 2D, 3D, and, because of Theorem 20, what we would call 4D. What does that mean? Well, if this cubic space is in effect his private oratory, and if that cubic space is what we would now call a hypercube and it's rotating through its center, that creates an energy flow that people would now describe as a vortex, a fill in your, there are fascinating energetic implications of that. I mean, a vortex, I hesitated because that's a word from Dee's time, but you have, say, a toroidal structure created by that vortex. You also have a mathematical way that the inside literally is the outside in 4 dimensions. That's why I was so excited about finding that in Theorem 20. Okay. So his astral structures should follow principles like the golden rectangle and its relation to the square and the phi or phi spiral. After this, so that's all I'm going to say about sacred geometry, although you can study that for the rest of your lifetime. It's a fascinating field of study. The next thing in this theorem is going to be charts of relationships between numbers that in effect review concepts from throughout the monad. Like, remember, 252 is the Philosopher's Stone, and why it was the Philosopher's Stone? Well, it'll reappear in these charts along with quite a few other things. But that's as far as we'll get with Theorem 23 today. We'll have one more video on it, looking at those charts, and then we'll move on to the final Theorem 24. Okay, have a great day, and see you next time. Bye-bye.